and
Good
thank you
evening.
for joining the session. We welcome you all to the 46th AstroTalk session of Amateur Astronomers Association Bombay. I would like to congratulate all of you for today's session along with the successful return of the NASA Canadian astronauts, 4 astronauts who have gone on 10-day missions to moon, and they didn't land but they were just on exploration and testing all the scientific components related to the Artemis program, and that's where we are heading towards. The now next mission is Artemis 3, where the date is yet to be announced, but probably in 1 year or 2 years, probably NASA plans to send human beings to land on moon. Probably this time, rather it's going to be the first man to be on the moon, but it would be probably a first woman to go on the moon. That's what the vision NASA is carrying, and that's what they're heading. So they basically their plans is now next step is to set up the base on the moon and explore the moon and its features, and probably it could become a hopping station or a gateway station further to do the further space exploration, maybe a second or the I would say pitch point from where we can go for a future missions, maybe Mars, Jupiter, Saturn's moons, all that thing. So today's talk is basically, I don't want to talk much about it because Sutar sir will talk about it. But interesting is that the second person from India who has gone into the space after the first person, Rakesh Sharma, almost 30, 40 years back, that was the case. Now it is last 1 year back, Group Captain Shubhanshu Shukla, who has using the NASA and EXOM spacecraft, he has gone into the space and visited International Space Station and conducted some important experiment with respect to the space exploration. And that whole journey, right from going to doing experiments and then coming back and then sharing all these observations, that is what we are going to hear from Sutar sir, where he will be telling about this. So before he talks about the Shubhanshu Shukla and his mission, let me give you the brief of Sutar sir. Professor Babasaheb Sutar sir from Jogalekar, Jogalekar College of Ratnagiri, Maharashtra. He is going to deliver. He has 25 years of experience teaching physics at UG and PG level. He has done MSc, MPhil from University of Mumbai. Being a very, I mean, say prominent coordinator from Astronomy Study Center at Gogate, Jogalekar College. He has done a lot of sessions for students, those who are interested in astronomy and physics related stuff. And he is member of ISRO Space Tutor also, researchers, Indian astronomy researchers. He has delivered a lot of sessions, lectures related to astronomy and subject. Passionate communicator related to astronomy and science, interacted almost, I would say, more than 10,000 students, delivered 25 plus lectures on Mangalyaan, Mars orbiter mission, and always in front to provide guidance to the students on various aspects, whether it could be a project, research, papers, essay competitions. I mean, he had been, I mean, he doesn't have a limitation of age and bar, would say, like he has tutored, guided people as small as possible to the higher side and all. I also learned a lot things from him during whatever the interaction. I mean, we had been interacting for last couple of years. I mean, almost 3, 4 years we have been interacted very closely and all. And special work and achievements from it was successfully organization of 12th state level astronomy research conference. That's where we first met physically, and that was just that experience has etched us in our memory, and we never forget the hospitality and the way he has organized the entire session. That point in time, those 2 days was very very memorable for us. Uh, then National Solar Calendar Communicator, member for Vinvan Bharti, Konkan Division, and IAPT. Public awareness, 12 public awareness programs on land parade, since December 2024 to March till 2025. Conference lectures on Shubhanshu Shukla. He has also delivered on 14th Astronomy Research Conference. So he is again delivering this similar lectures. Probably might have more information, more things to share. So with that, I would like to welcome Professor Babasaheb Sutar for today's AstroTalk number 46 to Amateur Astronomers Association. With that, over to you, Babasaheb.
Yes, sir. Thank you very much, Mangesh. And on the behalf of Amateur Astronomy Association, I'm very glad to talk about or share about this AX-4 mission of Shubhanshu Shukla. So I called this as a Shubham Bhavatu. The Shubham Bhavatu, we always talk about any puja or any great beginning. So we always say Sri Ganeshaya Namaha. So like in Indian astronomy or space science, I always say that it is a Shubham Bhavatu. So it is a story of dedication, story of success, and I would like to say story of Atmanirbhar Bharat. So though it is an astronomy lecture, it is I think it is interdisciplinary. Many aspects I have seen through his story, and I always want to share his story to different people, right from students to other community, general community. And this is my 7th lecture on Shubhanshu's achievement or India's this ISS mission. So whenever we talk about space, ISRO, ISS, etc., then these two figures we always keep in mind that Kalpana Chawla from Karnal to NASA, she unfortunately merged into universe, but she is a great inspiration for all the time. And another one is Sunita Williams. So she has also record-setting longest spacewalk, and so both of them ignited many minds in space science and astronomy, especially in India. So starting our journey with Shubhanshu, it is actually the 18 days and 7th experiments. I always quote this as in space. And Shubhanshu Shukla has the historical Gagani Yatri. We always say now not astronaut for Indian astronaut, we always say Gagani Yatri. So mission Gagani Yatri or Gaganyaan mission, he is the selected for Gaganyaan mission, and we know that first Indian to visit ISS and second Indian to go to space after 41 years. So the mission is AX-4 mission, which is by private organization. So many startups and big companies are now in space science and technology. Then we have collaborated with ISRO, NASA, AXIOM, and European Space Agency. So duration was 18 days, and after 41 years of wait, it has ended, and Shubhanshu has joined the International Space Station after Rakesh Sharma in 1984. So he's first Indian to visit the International Space Station, and really it is a proud moment for defense sector as well as a space scientist or space science. He is a group captain and born in Lucknow on 10th October 1985, Uttar Pradesh. Commissioned as a officer in Indian Air Force, commissioned officer in 2006. And he learned from NDA, and there is a very nice story that he was not present in his sister's wedding ceremony, and he went to Pune to give the entrance of that NDA exam. After that, he came back and say hi to her, his sister. So he has experience of 2,000 hours of flying, and he is called as a test pilot, and he has done many flying with Sukhoi 30 MiG series aeroplanes, which are fighter jets, especially. And in 2009, he had selected as a Gaganyaan for Gaganyaan mission. So this is Lucknow. We know that having traditional rich in culture, especially from Mughals. So this is one of the beautiful picture from a Lucknow house. And from that background, he came as a city of luxury. But made him a scientist as well as a first one to go to ISS. Basically, he learned from Indian Air Force the institution called as the Tactics and Air Combat Development Establishment. When you join as a in Indian Air Force as a test pilot, then only one top 1% of Indian Force Air Force pilots are chosen for such a mission. So 1% elite is very uh, therefore he is compatible and capable to join this Gaganyaan mission and Gaganyaan 3. 2000 plus hours of flawless high tech flight experiments experience, and he became a test pilot after become a commissioned officer. He became a test pilot in 2018. Then he was trained in Yuri Gagarin Cosmonaut Training Center. We know that it is a very rigorous training. You have to bear the 8G Earth's force or 8G times Earth's gravitation, which is equally like one motorcycle on your chest. You have to. Then microgravity simulation, you have to take the underwater training, and also some in emergency you have to take that training with fire and all different types of hurdles when you face in the space. Then they are trained for total isolation and in order to check the mental stability. So such a difficult training was there, and after that he was chosen as a uh, chosen for International Space Station, XM4 mission. We know that this is a big home away from Earth. That is the artificial home built. The most expensive one, $160 billion is the cost size as compared to the your football ground, and very large speed compared to the speed of sound, 23 times speed of sound. So it travels about 24,000 kilometers per hour. We'll see the little math about it. And it has four labs. This is the main skeleton diagram, I can say, of ISS. And Destiny is one of the. So these are the four compartments, we can say. One is Columbus by European Space Agency. Then Zveda is from Russia. Kibo Laboratory from Japan, and Destiny from USA. All these are laboratories as well as the living spaces they are using for ISS experimentation. It is on say 4 kilometers away from Earth, low Earth orbit we call it. And there is no gravity here, and you can no sense of up and down there, we can say. One day and one night comes, we'll see that 16 times day and night comes on this International Space Station. So a little bit of his flight, he started on June 25 at 12 p.m. Indian Standard Time, and using that Falcon 9's spaceship from Kennedy Space Center. They started their journey with other crew members to join the International Space Station. So this is one clip I show to students when
What?
So it is a very sentimental moment at that time.
Mother had tears in her eyes. Her father smiled with pride. Their son, Shubhanshu Shukla, was in space. He became the first Indian in 40 years to go to space. But his journey didn't start with a rocket. It started with a dream. As a boy, he was always drawn to the sky. He joined the Air Force, trained hard, and his parents stood by him every step of the way. Today, the whole nation is proud, smiles on every face, pride in every heart. And as he soared, his wife, his childhood friend, she held back her tears, her smile, her joy. It was his dream, but it belonged to all of them.
So this is very nice short film or shorts on YouTube. Then as soon as they went in space, immediately at a 70-kilometer altitude. After that, we know the usual sequence that T plus 2 minutes and 40 seconds. That is in the rocket science, we can say. The first stage separates, then second stage separates, and they go in space. So to go in space immediately is possible because of the little physics of escape velocity and all that thing. But to join the rotating ISS is very tricky job because you have to adjust the velocity and you have to join the ISS which is already moving around the Earth. So there are two processes. One is called as berthing, another is called as docking. So in first process, the ISS utilizes a robotic arm and you get attached, or ISS pulls you with that robotic arm. And another process is called as docking. So in this case, Shubhanshu's Dragon spacecraft, so that was actually docked with ISS. And if you remember that we also had done such an experiment for two satellites or docking experiments by ISRO recently, I think 2 or 3 months back. Then this is very technically uh, challenging thing that to dock the two stations or two units differently. So it took 28 hours to join and to get them into the International Space Station. So it's very it's challenging technology of this century, we can say. Then after that, after docking, they have to stabilize there. They have to stabilize the inner atmosphere, we can say, in the ISS because they have come from Earth with in the different capsule and they are docking and again joining the ISS. So it was really a challenging job. So there is a sequence that once it is docked, then ISS gets open, then crew floats in, as we see here. Then the equipments are transferred from cargo. The current ISS crew, which in the case of Shubhanshu also there were previous crew, they welcome them, and after that they get joined, and then after that ISS seals the gate again, and so all the new crew they join and become member of ISS mission. So here is a little bit maths. So ISS orbits the Earth so quickly that there are 16 sunrises and sunsets every day, and that affects our biological clock. So is there gravity? We can say because ISS in space, so is there gravity? We can say, or that the question is asked, what happens about the gravity on ISS? So it is actually not a zero gravity, but microgravity we can say. Zero gravity means actually zero, but here we say that it is a microgravity, and with this graph we can say that how it is experienced. So you take a flight within a very short interval of time, get accelerated at a high altitude, and within this region of 20 to 45 seconds, we reach the stage which is called as microgravity or zero gravity, and that is the weightlessness situation. So there is no force acting literally on your body. So F is equal to mg or F is equal to g m1 m2 by r square doesn't hold here, and literally we get or the body or the astronaut are floating in this situation. So such kind of tunnels are developed, and astronauts are trained to remain or to experience this zero gravity. So that is called as a microgravity. So if Earth has a 1 g force, then on Moon we have 0.18 g. That is the gravity, and on ISS we can say that it is a zero or a microgravity. So gravity here is a very low compared to the gravity of Earth. Then we know that this is famous picture of the great scientist Stephen Hawking, cosmology, and the science in microgravity we take a look, which is very different in microgravity. Here on Earth we see that the flame is due to the because convention is there, heat convention, process of heat radiation is different in space as compared to the Earth. So there is no force at all. So we'll see that in microgravity the flame is spherical like this, and flame on Earth is somewhat elongated because convention and all these conduction, all these processes are there, and gravity is mainly present. Therefore, the flame is like this. Then we are actually floating, and we'll see the hairs of the astronaut. So if you are not tied them, then they are floating. Then a little bit of daily schedule on ISS we can say. So they are wake up at 6 a.m. and in their this special bedroom, and this special arrangement for using sleeping bag, well tied, and like a phone booth size cabin. And they don't float around sleeping because of the bag is tied, and due to the lack of gravity they have to tie that bag and insert the body inside this bag, we can say. You cannot brush, or if you brush then you have to swallow it. This is the picture of Sunita Williams, we say that. So, because everything is weightless here, everything floats. So a very micro particle or minute particle can float, and it may damage the instruments, or it may go somewhere else, so you cannot control it. Then there is no shower. So we cannot have a shower on ISS, but the shower not possible, but we can have another solution for this. Warm water bag or ice you can take. Then hair cutting is also like you have to take some machine like a vacuum cleaner and catch every hair or a minute part of the hair, we can say that, very small pieces, and we have to collect it. Then we cannot walk on ISS because we are always floating. So you have to push your body, keep anything, you have to hold it, and Velcro is used a lot of times. So that is the case. And this the life is totally different on ISS, we can say, and the people or the astronauts are trained to get acquainted with this life. Then space laboratory, you have to work there, all the different kinds of instruments. So Shubhanshu is basically from Though he is from engineering background and Indian from Indian Air Force, so he has to learn lot of new things technologically and scientifically also. He had trained and get acquainted, well acquainted with the ISS machineries. So basic uh, study on ISS is how science and technology works in that zero gravity or weightlessness. So study of effect of gravity on animals, plants, all these things. And here there is a jargon. People say that the scientist or the astronaut on ISS, they are guinea pig because most of the time they work as a guinea pig and they do experimentation on their own. So this is the gem in zero gravity. You have to get tied yourself. Otherwise, you obey Newton's first law, and if no force is acting, then you may get thrown away from the cabin, or if you are not tied, then that is harmful thing. Then you cannot sit there because the sitting concept is not applicable in ISS. Either you have to hold something and you have to attach you have to attach yourself at some body or at some instrument there. So this is a different kind of situation there. Then you cannot eat directly. You cannot enjoy your food there, but there is a provision that you can eat powdered eggs or anything in the powder form, but you have to suck it always. Okay, because a small crumb of bread can harm your eyes, your body, or the instruments, very sensitive instruments on ISS. So everything liquid form you have to consume it by straw, and other solid things you have to eat carefully. Then this is very challenging to have a lunch, different types of lunch items. So in weightlessness, there is a called as space snuffles. So stuffy nose. So because we know that we can taste by means of some part of nose or cells, they are responsible to get knowledge of taste. So due to this snuffling, we cannot have the smell of the food. So to make it tasty and to get a smell, you have to use salt and other sauces, etc., in order to make your dinner or lunch in happy environment. Then water is the main crisis. We say that it is crisis on Earth also, but it is great crisis on ISS because 70% water is recycled. So everything available in the water form, urine and sweet, it is recycled. And again, there is a jargon in space science that today's coffee is also tomorrow's coffee, or today's coffee is tomorrow's coffee. So again, another thing, the astronaut or the space scientist working there on ISS, they have to, it is a mandate that they have to work for ISS. So that is called as a spacewalk, and Sunita Williams had made a record for it. Then why these people are doing, or why the astronauts or NASA or all our Gagan Yatris are going to do this? Because it is a challenging, basically they are facing the challenges like tasteless food, lack of bathing, noise of ISS, floating in zero gravity, and what they will get. They will get they are doing the research for humanity, and that is the reward, we can say. It was started in 1961 when Yuri Gagarin was the first astronaut went in space, and that the journey we know all the history of the space science and the space race. But since ISS, the study of the space science and technology is very different. And one of the challenging thing, or one of the we can say that is the limitation of nature, that we as a human being are not designed to spare life in space. So for us, space science and life in space is very different.
Babasaheb, I think if you have transitioned the slide, we are not able to see. Your audio is also not coming.
Yeah, that is the I think the first building block of the food chain, and therefore to cultivate the microalgae for long-term sustainable food is very important. So next, sir. Next. So this is the infographic. Also, we can skip this. We can skip this, sir. This is there are two types. One is the blue-green algae that is also called as cyanobacteria, and that is also means microalgae depend on this cyanobacteria, and cyanobacteria are the microorganisms which are using light and using photosynthesis. They can fade to microalgae, and microalgae depending some species which are depending on microalgae, or entire food chain after that depends on microalgae. So cultivation of cyanobacteria, that experiment was also done by Shubhanshu. Next. Next, that we have seen. In PDF, there are some additional slides. Then seed sprouting was done. He used methi and moog to cultivate, because these are the superfoods, and to sprouting on weightlessness or zero gravity is very important. That can help on agriculture on Earth also. Next. Next, sir. This is just visualization. So these are the superfoods, and why these crops were selected. Uh, Many agriculture, because of protein, they are protein rich, and having Indian origins or Indian centric agriculture. So fresh food astronaut may for future mission they can use them. So Shukla done the experiment on this space farming also. Usually these experimentations are regularly done on ISS. Next, sir. Then pulses, crop seeds also they cultivated. And this one is very important, tardigrade study. So tardigrades are the microorganisms. They are very, means Indian tardigrades are of different kind, and they are very sturdy, and they can sustain in any odd type of situations. So this can be helpful for future research regarding Gaganyaan or all future missions. Okay. That is why tardigrade study was done by Shubhanshu. Next. Next. So this is in myogenesis, that is that we know that we can lose muscles because the entire fluid dynamics in space changes because of the zero gravity, and that is why we see that left side the healthy muscle, and when you are in the zero gravity or without gravity, then the muscle fiber uh, they are decreasing and we are losing them. Okay, so that is why a very important study he has done in on ISS. Next, so Voyager display means it is very simple thing. Actually, we are coordinating a lot of digital display, or we are in the digital world, and in future uh, on ISS or any kind of such mission, we are always dealing with touch screens and digital display. So while remaining in floating situation, to coordinate with the displays, coordinate your eyesight, and accordingly the signal generated in your brain. So that is has some complicated phenomenon. So that is I actually translated that in English also. But this Voyager display research next. So that was a diary actually made of 18 days. So we can quickly go through this. Shubhanshu has done on 20 June. He has the conversation with Pradhan Mantri ji, and there is a very funny clip that he said that Pradhan Mantri ji मेरे पैर बंधे हुए हैं लेकिन मेरा माइक फ्लोटिंग है और उन्होंने he asked Modi ji asked how India is looking. Again, he told that the famous quote by Rakesh Sharma that सारे जहां से अच्छा. फिर भी इंडिया अभी भी सारे जहां से अच्छा दिखता है. नेक्स्ट. So next, this he has done a lot of photography, and they have taken they have taken means normal schedule like they have some holidays, then they have parties, all these things they enjoyed. They communicated with the students, citizens, and with their families. So the life on ISS was, but still the culturally rich and members were very cooperative. Members were very cooperative. So what he quoted that proud to represent India, the mission is tribute to every scientist and engineer and citizen who believed we could reach for the stars again. So that was his message. Next, he has been nice party of food actually which kind of food we can eat. So they enjoyed halwa and amras also in space. Okay, Ratnagiri is famous for Alfonso, and okay, next. Then he was called as Sux in by their colleagues. Next, I think we are at the end, and this is very nice clip and is like, 2 to 3 minutes long speech. So what he said that today's India is fearless. Yeah, we are confident and we are proud of, and still it is Sare Jahan Se Acha. He told again, and that is the nice clip actually when they came back and splashed down like today's Artemis 2 crew landed on Earth. Next, it will not run because of the PDF. Again, next, that is this, why this ISS expedition, commercial expedition is important, because we have learned lot of things for Gaganyaan. Actually, that docking experiment ISRO has done, that is also part of Gaganyaan mission. And Shubhanshu has learned that docking procedure with ISS. And this Means it will contribute a lot of things to Gaganyaan mission also, because a lot of commercial aspects are there. Next. So major objectives promoting private research in low Earth orbit, because now the startups and companies which are coming in India also in space technology and science. So this experiment will also helpful for them. Then biological research and research in microgravity will also help in Indian context. What he has done. Then international cooperation, so to accompany with the different cultures and all that thing, that is also important. That also we learned from that mission. Next. So message to the nation: I'm proud, and after that, proud to represent India. Mission is, and we could embrace the stars once again. That is, he told. Next. Therefore, he received this honor, Ashok Chakra honor, from Honorable Rashtrapati. Next, Modi also, Modi meets astronaut Shubhanshu Shukla. Generally, people meet PM Narendra Modi ji, but here that is the reverse. Modi went and met him to honor him and to give some appreciation of his achievement. Yes, next. So benefits of space research for that is based on biological, basically biological and agriculture. But osteoporosis techniques can be developed to treat osteoporosis, and muscle anthropy, that is another. This drug, which will help in drug discovery. Then tissue regeneration, that is what happens at biological level. So that research in space science is already, we can say, by technology transfer, that at last which comes to common citizens. Like we have GPS system, mobile system, all these things are came from this. In future, yes, in future we can have sustainable uh, habitation or sustainable agriculture on different planets like Mars. Then our, yes, you can go, sir. Our wheels of progress started in 1969, and Shubhanshu's this expedition 2026. So after 75 years, we have reached, and we have crossed many miles and many achievements in as a Indian space science, Indian space and science and technology. Yes. FSA said that dreams, about dreams, which is not what you see in sleep, but the thing which doesn't let you sleep. And Sarabhai told that who one can listen to the music in midst of the noise, achieve great things. So we have a lot of problems. Our country has a lot of problems. So that is called as noise, and the music means the progress in science and technology. So that will achieve the great things. So these are the two good sentences, and based on that, we can say that Shubhamshu's mission is not a journey, but an example of how Indian science and technology can contribute to the welfare of humanity. So, thank you very much, and very sorry for the trouble due to network issues. I will resolve it afterwards, but I think there is a problem. So, many thanks, Mangesh and Bharat sir, and all the participants. I will share this original PDF presentation, so you can mail them.
Yeah, yeah,
Other people.
definitely. Sutar sir, it was really interesting, and though we had that technical challenge at point due to some network issue, but your detailed overview of research conducted by Indian astronauts Shubhanshu Shukla was really enlightening for every one of us. The insight, basically the insight what you gave on the microgravity experiments from muscle growth to tardigrades, and it has given us a lot of insight into future space exploration, as well as your interest in highlighting both the scientific triumphs and the human challenges of the missions, which are really required and incredibly inspiring for us for the future space exploration. Uh, Definitely, Amateur Astronomers Association Bombay would like to thank you for sharing your expertise and passion with us today. And definitely would like to hear from you on different topics related
Yeah.
to astronomy and space exploration in near future.
Yes,
So
sir.
thank
Sure.
you very much for that part. If there is any question from anyone, we can take up quickly couple of questions because we are already overshooted by 40
Yes.
45 minutes. But
Yeah.
anyway,
Yeah.
we would see if anybody has any question. Anyone has any question, please feel free to put up forward.
Uh, Hello.
Yeah,
Yes,
brother.
sir. Yes, sir.
I have a small query. As I said earlier, that Rajiv has some videos for the meteor. If there is some time, can we see those also as a part of Baba Sutar's lecture?
I think Ravi is not there on a call as of now.
Okay. So
So
my
we are
question
just
is very, yeah.
go ahead, sir. Go
Hmm.
ahead.
My question, second question is, were there no physics or astrophysics uh, part taken up by astronaut Shukla? This is my question to the speaker today.
Yeah, actually, physics experimentation is not done on ISS. Basically, the experimentation done or maybe the mandates they have given basically on biological aspects and agricultural aspects they have done. But there are beautiful experimentation demonstrations by astronauts. So how physics is different in gravitational environment. So if because uh, there is a, a lot of videos available also or demonstrations also available, and the the role is mainly because of the conservation of angular momentum and or more conservation principles. And in weightlessness, uh, we play always with the Newton's first law that if a body is moving in a straight line, then it goes in a straight line. Then you can verify the second law. So such kind of experiments actually they have not done because their main mandate was different to study the biological aspects and agricultural aspects.
No, my question particularly has been on uh, crystals growth under microgravity. Was there any kind of work done on crystals?
Hmm. I have no idea, sir. On ISS, I think that much I have studied, but there is no such kind of thing, growing crystals in weightlessness. But they have done some chemistry, like the frame I shown that flame is different in microgravity, and your battery cells and electrolysis reactions are different in microgravity. That is done actually on ISS.
Thank you so much. And
Yes,
nice
sir.
talk of yours.
Really sorry, but I don't know what happened, but I will resolve the problem. Maybe due to
There is
the
one question, sir, for you in a chat. I have posted it. What I received. I mean, this is from one of our college students who is watching you on the YouTube. So he said, "How does the participation of Indian astronaut in NASA dock mission via exam impacted the future?" Like I think you gave example related the docking mechanism. What was actually studied where Shubhanshu Shukla participated and it could probably help in future Gaganyaan mission docking system, or even the 2 satellites docking, which was we have
Yeah.
done. You want to add
Yeah,
something?
yeah. Please, satellite talking. ISRO is sir.
Hello.
Yes, sir.
You want
Can
to
you
add anything to that docking mechanism or something like that?
read that? Yeah, in docking mechanism, the docking mechanism is now a usual practice on ISS, and ISRO with our instrumentation and our communication system already done it. I think 3 or 4 months back, and that will help in Gaganyaan mission. So, in order to dock the different instruments or to connect two different devices in space by our control center. So that is the idea of docking. Another thing that mentioned is the berthing, where ISS robotic probe can capture the device and that can be connected to the ISS. So that is another thing. Is it clear? I hope.
Yes, yes, sir. Thank you very much for that question. Just give me a minute. Let me check if there is any other question from anyone.
Yeah.
Bharat sir, you want to add something on a closing note? Meanwhile,
The lecture was really excellent. I hope we happen to have such detailed reports on the astronauts and the kind of work that they have been doing. Professor Sutar, I definitely would look forward to your write-up on the same.
Yes.
Thank you very much. Thank you so much.
Actually, I published this article about how should expedition in Marathi newspapers. Uh, I can translate it and forward.
yeah, that would be really great help, sir. Basically, that would basically
Yeah.
let all the students. I mean, we can share it to all our other school groups and college groups also here in Mumbai, and
Yes.
probably if somebody is interested to have you again on this particular topic, then we can ask them to connect you directly also, something like that, so that the experiments and the research done on the ISS by the Indian astronauts could reach more and more people, and then could probably inspire them to come ahead on this kind of practice.
Yes.
Anybody else has any question, or we can conclude today's session? So with that note, I don't see anybody raising hand, but Sutar sir, thank you very much for the today's session, and definitely we would like to hear you in near future more about talking on astronomy and space exploration.
Yes.
Things.
Yeah.
Thank you very much on behalf of Amateur Astronomers Association Bombay. Thank
I will
you.
make my setup technologically sound to deliver such kind of technological.
yes. In that case,
I will upgrade it.
yeah, in that case, you need any help, please reach out to me directly. We will definitely
Yeah,
like
yeah.
to help you and
Yes, sir.
take that from. Thank you, sir. Thank you,
Thank
Sutar sir. Thank you, Bharat sir. Thank you, Arjun. I think Arjun from Karnataka has also joined. He also conducts
Yeah,
similar kind of sessions. Arjun, anything you want to add before we conclude the session today? You want to put up something?
No, sir.
Okay. Thank you, Arjun. So with that, we will conclude today's session. Thank you, Sutar sir, Bharat sir, Arjun, and Astronomer Bombay Saivi. Thank you for hosting us on the platform. Thank you very much. Sutar sir, we will be posting your video on the YouTube channel shortly, and once it is available, we'll share you the link. Okay, sir?
Yes, sir.
Thank you.
Thank you.
Thank you.
Sure,
very
sir.
much.
Thank you.